My name is Jerry Schneider, and I'm basically a single-employed, self-employed person. What we're going to try to do today is, in no more than 20 minutes, if we can't go through almost nothing about myself, quick background review for anybody that that needs to come up to speed. Those of you who know what's going on, I'll try to make it real quick. We're going to look at how Windows client implements DNS, just a little bit from kind of the light reverse engineering side of it. Look at a couple exploit techniques, one of them that's fairly easy and one that's, or a couple that are fairly hard, and talk a little bit about like what you might do if you're trying to figure out how to block this stuff or detect it or filter it out. And then try to leave some time for questions. I basically, who am I and why am I here? This isn't my philosophy class, although I wish it was. I'm more or less a device driver writer, and I work a lot with the guys who do the hacks and the guys who are really good at finding the exploits. And so I just basically found that I loved this area. So I put my work to digging through the kernel, the operating systems and stuff like that to use. And I just happened to stumble on a couple of things that I thought might be interesting, and sure enough, they were. About the only experience I have security-wise is like when I was working at WebRoot, they basically had most of the SpiceSweeper and the user mode side, and when I got there, I was basically said, let's move all this stuff down to the kernel, let's put our gnarly fingers down in where Microsoft doesn't want us to get there, and let's see if we can do it without making blue screens. And so that's where it came from. I have a front company, I have to have something for the business card, so I put it on there. I kind of do contracting, driver development, and stuff like that. And I looked around, and the only black hat picture I could find was one my wife took of me a few years ago, and so I guess that's my black hat pick. So what we're going to look at is make sure everybody understands the difference between what you think of as a normal name server and what you call the client DNS resolvers. Look at the internal implementations, look at some serious, well, possibly serious implications that cache poisoning can do, and look at some of the exploits and how to detect and block them. So first thing is like, what's a DNS? Well, it's a TLA for domain name system. And TLA, if you don't know, is a three-letter acronym. So it's sort of redundant. More or less, DNS is going to be used to map a human-readable computer name into an associated IP address, google.com into some IP number. It's more or less the phone book for the internet, and it works kind of like calling directory assistance to get the phone number of some person. And I can type Google into my system, and directory assistance, the DNS, will give me back 72.14253.99, which I think is their stuff. So what's a DNS server? Well, it's basically a program that can run on a network-connected PC. It normally runs on a PC that's kind of dedicated or isolated, kind of you don't want to have a lot of other stuff running because you don't want the security complications. And it's basically, each DNS server is responsible for a subset of the domain that's out there, the namespace. In other words, you have a few root servers that kind of know how to point you at subdomain places, but if you work at a company, your DNS server or your host probably knows all about the internal domain, but it doesn't know much about anything else. And so it works like a kind of a functional hierarchy of domain name servers. They work kind of like the telephone directory assistants. You're here in Las Vegas and you say, what's the phone number of Harrah's or of the Caesars, and they turn around and look it up for you and tell you what's going on. Now, what will happen is if somebody does this, it takes a little bit of time for them to go out and look up the phone number for you, and particularly if you were going to do something like call to ask for George Bush's phone number, they'd have to go to Washington, D.C. and find out what the number is and come back and tell you. So more or less, a cache is used to hold a copy of something that is expensive to reacquire. So if it's something that you can calculate really easily, you don't need it. The cache is more or less says, oh, I looked that up once, I'm just going to hang on to it for a little while. Now, one of the things you need is if you're going to hang on to stuff for a little while is you really want to know, I wonder if the president got reelected or if there's a new president, and so therefore I should purge my cache of phone numbers, fairly frequently so that the stale ones don't build up or we don't go to the wrong place. So the other thing is that it's very useful to not only cache the telephone number of somebody that you've looked up before, but say you've got some drunk and you're in directory assistance and the person keeps asking for, the showgirl's number in town, and you say there really isn't a number for that, but you put it in the cache so that all the operators know that when the drunk calls up again, you don't have to go digging through the phone book. You can just say, hey, there are no showgirl phone numbers here in town. And, of course, the time to live is useful in that case, too. How long should I keep this record that there are no showgirls? Well, who knows if, maybe the next president will have the showgirls in the Lincoln bedroom, so it might be useful to have the ability to purge that and start over. So what is DNS poisoning? Well, basically it's as simple as saying if anybody illicitly goes into your cache where you've saved these relationships between names and numbers, and if they illicitly modify some of that information without the DNS system being aware of it, people are going to be going to the wrong places. It would be if somebody came in and put the president's phone number, poisoned it, and pointed it to the showgirls. And so somebody calls the president, and they get the showgirls. And so they're going to be kind of bummed out about that. So one of the reasons that the time to live is valuable is that if somebody poisons something, they have to tell it, like, how long do I want this bad name to be in there? And so you could say, well, leave this thing in there for 10 weeks. But then a lot of people might look through their cache and they say, gee, there's one entry in here that says, leave this thing in for 10 weeks. Everybody else is in there for 24 hours or, maybe 3 or 4 days, sometimes a week. 10 weeks is a little high, so it might be a trigger point that you could use to, pick out something's not right. So hopefully the time to live will help pull it off. Another thing that's important about the DNS poisoning is that the discovery, in other words, how soon will it be before somebody reports that when he calls the president, he's getting the showgirls. It's hastened by how broad the landscape is of the cache. In other words, if we poisoned the phone directory for all of Nevada, that's more likely that somebody's going to call a bad number and report it than if we just have the phone number system for Las Vegas and have a few poison entries there. Poison the one in the United States, and we'll find it in 5 minutes. So the corollary is that discovery is less likely the fewer queries that are made on something. And the reason that's important in security is that you really, in these days, try to target a few individuals. I mean, a lot of you've heard of the exploits where you're trying to target a few people at a company. You don't want to target the whole company. And having a fairly narrow beam on your poisoning allows you to minimize the chance of being discovered, which people are going for that. So I think you're going to find that tricks that people want to use that have narrow beam, but they get to high-powered people are going to be more and more prevalent as we keep looking in the security field. So poisoning my DNS cache, a lot of people say, well, wait a minute, this went around 2 years ago, and our corporate DNS server, it's all patched against cache poisoning. I mean, hey, we got split DNS servers, so recursive lookups don't really have a problem. And we actively monitor DNS servers, and hey, we're safe, aren't we? I mean, we've been doing this, and we should be safe. And I guess the question is like, well, yeah, the classic DNS server poisonings were zone reloading exploits, response spoofs, and things like that, and they are pretty safe. But what we're talking about here is a client resolver. DNS resolver is often, when you think of it, people think of it as part of a server. And actually, it turns out the performance gains and low network traffic that you get from a resolver works really well in a PC. So instead of me having to go out on my dial-up connection and look at something, or I can turn around and have a cache of IPs for particular names, and I get a performance. So Microsoft, since Windows NT, has been building an internal DNS server into the system, and if you go look around, you can find a service that winds up loading DNS resolver.dll and loads that in, and it starts up when you boot, and it more or less has an RPC interface that allows all the programs that need to ask for the IP from the name, your emailers, web browsers, IM clients, pretty much the standard stuff. So what do they do in Windows? Well, it turns out that the DNS resolver service it has 3 exportable functions, and it just looks like it's pretty hard to get a hold of. So what it does is when it goes in and loads up, it does 2 things. It statically binds with DNSAPI.dll, And that's the guy that's got all the functions that you probably want to call. I mean, they're kind of like the low-level stuff under get host by name and things like that, query results. So DNS API is more or less the interface. And DNS API talks to the service through RPC, as does WinSAC. And this is kind of a little bit of a loose interpretation. This is a very complex thing that Microsoft has put together. So I'm playing a little loose with the definition here. The reason that it has to look in the WinSock is because if you think about a query going out, something goes out to a DNS server, it's got to come back up the protocol stack, and some place it says, oh, this is a DNS thing, let me turn around and throw this back up RPC, the answer back into the DNS, the resolver cache, so it can figure out what's going on. So, and then you have other commands like you can type ipconfig and display the DNS, and it basically is going to go through there, talk to the RPC, which is going to come along and say, oh, he wants to know what all the values are in the queue, and it's going to dump it back out. So that's kind of what they've got. So I'm going to speed up here a little bit. Basically, we're analyzing this. We do things like stick in the debug versions from the MSDN. You can turn on a log file that Microsoft has conveniently built into the DNS, and you can use your WinDebugger to go into the system and put breakpoints and to set some logging flags and enable logging to memory. They have a very high performance log that allows them to log essentially into a circular buffer in memory. You can, when you stop in a breakpoint, you go look at the stuff, and it gives you a nice picture of what's going on. This is essentially, anybody can create a DNS resolver.log file in the System32 directory. The big magic is that since the resolver runs under network service, what you got to do is you got to set the ACL for the log file to give network service permission to run to the file. And so if you're having DNS issues, you can do this. You don't have to be trying to reverse engineer it. It'll give you a chance to see what's really going on in the resolver cache. Turns out you got to stop and restart the cache for it to recognize that, and you can run your tail on it. So let's talk about first the easy client exploit. Back, gosh, I think it was 3, 4, 5 years ago, someplace, it's a long time ago, mydoom.b, it was a virus, that one of the things that came out, and it worked pretty much by, one of the things it did was it went to the host file and it said, I'm going to set up a mapping to 127.0.0.1 for things like Symantec, download Microsoft's update. In other words, anytime you got the virus, you want to figure out how to get rid of it, I'm going to try to plug up all the holes so you can't get out on the internet. And so we figured, heck, that's been, that problem's been solved 2 or 3 years ago, because most of the anti-malware these days monitors the host file and says, hey, who's trying to write to this? If it's somebody that shouldn't be doing it, I'll prevent it, or at least I'll put it in my 0 day, and that helps me go. So we really shouldn't have a problem with the host file, but if you look at there's something called internet connection sharing that a lot of times if you're at home, you might set it up if you don't have your own router, God forbid. You make one PC essentially the router, NAT translator, and all the other PCs talk to your PC, and they use a file called hosts.ics. And they use this mostly to set up the connections between all the little local things and point it out. But it turns out that the hosts.ics file is loaded by the DNS resolver. It does the same thing as the host file. And on Vista and on XP, if you want to go in, if you've got administrator privileges, you don't have to have network services. You can go in, create a file, you can put anything you want to in it, and when it's loaded back into the domain server, essentially you've got a poison cache. So, I mean, that it's like a twin of what we had before. The one caveat is that in this case, it's only loaded when the server starts up again, so you might have to write the file and then blue screen the PC or something to cause it to reboot. And but that's one area that I think needs to will probably get plugged up pretty quickly by the vendors out there. Now, the more difficult ones to do are things like DNS cache poisoning. One of the things you can do is, like I said, it's an RPC interface to the server, and if you go back to when they first put it in there was almost no security on the RPC. You could just about call it from any function you wanted to. On Windows XP Service Pack 1, it's still, there were several exploits out there, not very well published, that were able to do it. And on XP 2, there are still some sneaky ways of getting around it, but it's a little hard. Now, it turns out that under Vista, it's very hard to do because they plugged up the holes pretty good. on the RPC, you have to have some pretty hard to get ACLs and things to get in the system, and it's kind of hard to get there. The other thing is that if you're not going to talk the RPC, how about if you go around and send some packets back up from a computer, maybe the one that's being attacked to itself or to another one on the LAN, and say, oh, by the way, you went out and asked for what the IP address of something was. I'll go through and tell you what it is. And I'm going to skip these RPC interface things because we're short on time here. Okay, so the spoofing DNS, yeah, okay. So what we're trying to do is we're saying, okay, if I create a packet that I send back, it turns out that DNS is fairly flexible in what it receives, although you're supposed to match the source IP and an address going out and coming back in. They really don't. If you look through this list, like the fourth one, the destination port number must match. The sixth one, the transaction ID must match. And the last one, you must set it up in timing-wise so that if someone queries, the answer comes back, the bad answer you're going to give comes back before the real answer comes back from the domain name server. So one of the first issues they had was how do you spoof this thing and guess the domain number? Well, it turns out that if you remember in high school or classes, a lot of times people would say, hey, the probability of two students having the same birthday in a class of 23 is like over 50%. And this is because of the fact that it's like 20 people times 20 people across the possibilities. It's a lot more common than you'd think. So it turns out that using the formula that if I'm trying to guess a number, I have a 50% chance of just randomly picking 260 numbers that one of those numbers will match an ID of something that goes out. So this is how a lot of times they attack the problem of how do you guess what the ID for the transaction is. Now it turns out if you're surfing or if you're actually sniffing the network, you don't have to go through that, but this is sort of one of the attacks that if you can't do it, you can get there. What can we put in our response when it goes back? One of the things is that it'll accept, if you ask for one name, something like google.com, it can return back not only the address for google.com, but from exploit.foo and things like that. So you can actually add extra answers into the DNS reply. And in most cases, there's some things it won't catch, but most of the time it'll go in through and float into the kernel, or into the DNS cache. Now, Windows Vista actually does a pretty good job of looking for that stuff. XP Service Pack 2, it seems to have sort of a hit and miss kind of a thing. Like some things it finds, some things it doesn't. So, turns out, interestingly enough, there are a few things now since mydoom.b, I think, that was made. If you go look through the strings that are in your API, all of these names in here happen to be something that they don't use DNS for, they don't use the cache for. It's like they've hard-coded what to do. So you can poison all you want to in the cache, and you can still get to office.microsoft.com to get a patch. So it's something that would be nice if it was available for other vendors to be able to use too, the same technique. So when we talk about countering these things, I think one of the first things you should do is you should monitor this host.ics file to watch for writes. You can watch for DNS overwrites. In other words, if somebody comes into the cache and changes the IP address associated with something, that's probably not likely to happen in real time, so that's probably a good day zero kind of a thing. If you're looking for bursts of DNS, the way you slow down the DNS server, the real one, so you can get your spoof in, is you send it a whole bunch of requests, hope it gets busy, and you get your spoof in before it comes back. So looking for bursts of traffic like that on the LAN is another way of doing this. So we can look and see who's adding records to the DNS cache, if you're going to watch this, who's accessing the files. We want to maybe look at the response in the DNS to see if there are additional answers coming back that shouldn't be. And you might want to turn around then and try to monitor the LPC and RPC connections to the DNS service. So I rushed through that, and I think there's not even enough time for questions and answers. I'll be around if someone wants to talk to me afterward.